Now that we have seen various network elements that are present in the LTE network, let us see if a mobile wants to connect to the IP network, what are all the interfaces that it has to go through and what are all the protocols that are involved in communicating with the IP network. So as we see in the diagram that is present in the left, the little phone, the first connects to the E node B via UU interface, also called as air interface, and then that particular data has to go through S1 user plane interface to S gateway, and then S gateway routes that particular data to S5 packet gateway via S5 interface, and finally the data reaches IP networks via SGI interface. And we could see parallelly there's a control plane route as well from UU interface through UU interface from mobile to E node B and S1 control plane interface to mobility management entity. Now let's see the various protocol stacks that are involved in this particular communication of routing the user plane data. We'll see as we see that the data is originating from the application layer present at the top. Then comes the IP layer, and these packets of this IP packets are transferred to PDCP layer in LTE UU interface. Then PDCP layer communicates to RLC layer, radio link control layer. Then it communicates to MAC layer. Then from MAC layer, the packets are, I mean, the packets, we should not call it as packets. The data is transferred to the physical layer. It is this protocol stack from this PDCP layer to the physical layer is called as LTE radio bearer. This LTE radio bearer then communicates in a similar fashion to the S1 bearer, and S1 bearer communicates with S5 bearer, that is from S gateway to packet gateway, and it is the combination of these three bearers, that is LTE radio bearer, S1 bearer and SV5 bearer, is called as EPS bearer. This EPS bearer is the bearer which carries the user plane or user data over this LTE network from end to end. If you want to dig in more details about what are the various functionalities of each layer or each protocol stack, the references are given below. If you just Google out the particular uh, 3GPP standard number, you can find out the more details clearly there. Now let us see the user plane data traffic as well. Sorry, user plane data protocol stack as well. So now here see that, sorry, now let us see the control plane traffic protocol stacks as well. As as the application layer generates the data in the top in user plane data in the user plane traffic. Here the control plane traffic originates from NAS layer. NAS stands for non-access stratum. It actually runs between UE to MME. We'll see more about this layer or what is that functionality in the coming slides. In LTE UU interface, now we see a new layer called as RRC, which stands for Radio Resource Control. This RRC is present only in control plane and it does not present in user plane, as it does not touch any of the user plane data. Then comes the PDCP and RLC MAC physical layer, as we have seen before in LTE UU interface in user plane. Then comes S1 control plane. It's a split of S1 interface which has both control plane and user plane. The key other protocol stack that are present in this particular diagram is X2 interface, which is used for communication between two E-node bays for mobility management like handover, radio load balancing, etc. And S11 interface is the interface with which mobility management entity is communicate communicates with serving gateway for EPS bearer management, as we have seen before. And this is a protocol stack between those two interfaces, those two network elements in this interface. As I said, if you want to dig in more details about this particular of any uh, particular topic which is present here, the references are given. You can just Google it out and know more about those particular network elements.